Today we're going to talk about reflections. A reflection is a type of transformation that creates a mirror image of the pre-image across the line of reflection. In other words, a transformation is the operation that maps the pre-image, the before, onto the image, the after. Now, for reflection, the before, the pre-image, is flipped over a line, and this line is called the line of reflection. So let's start with an XY axis and see if we can show this to you. This is our X and this is our Y. And I think I'm going to use the letter P. So let's start with a P. If P is reflected over the X-axis, it's going to look like this. And now let's go look at the formula. Suppose we have a point right here and it's going to be 3, 4. If this is reflected over the X-axis, the X stays the same and the Y goes negative. And there's a formula right here. So 3, 4 over the X-axis, it maps to 3, negative 4. Now let's reflect this over the Y-axis. It's going to go and look like this. It's folded over. Might me move over a little bit, but that's the general idea. So now a point 3, 4 maps to negative 3, 4. And similarly, if we were to draw the line y equals x, then the 3, 4 maps to 4, 3. Let's go show this in Geogebra. Alright, I already have someone that I was working with right here, so let me first talk about the quadrants. Here's my Move Graphics view. The quadrants in Geogebra are labeled with Roman numerals. Here's quadrant 1, 2, 3, these are the different areas of the XY axes, and 4. So I'm going to ask you to draw a polygon in quadrant 2. And we're going to show you how to reflect it across a line. To do that, you use this reflect about a line. It says, let me just go hover over it again and see if I can get it. Select object to reflect and line of reflection. So we're going to reflect it over the y-axis. So here, click on the y-axis, and it reflects over to here. The points A, B, C change their orientation because if you look at them here, they're going the counterclockwise direction and now they're going the clockwise direction. So they change their orientation, but everything else about them, they're the same. They're actually called an isometry because the pre-image and the image are congruent. Let's write these words in. Pre-image, and this is the image. If you were to draw a line or line segment from A to A prime, let's do this segment. I did a line tool. A to A prime and mapping C to C prime, you'll find that if you find, let's go find the distances along this line of reflection, which is the y-axis, which is x equals 0, and we find the distance using this distance from A to D is going to match the distance from D to A prime. Similarly, C to E is going to match the distance from E to C prime. So I can move these out a little bit so they're a little bit more friendly to look at. And if I change my pre-image, this is always true. Now let me show you a few more things you can do in Geogebra. So let's draw a polygon in our triangle we'll do in quadrant 4. Let's reflect this over the line y equals x. You go to the input y equals x. We're going to reflect it, go in the middle of this, click on the line, try it again. Sometimes I have to release it and start all over again. So go in the middle of this, it says highlight, and it didn't work. Try it again. And there it's reflected. So that's how you reflect over a line. Now sometimes you don't really know where it's been reflected, so let me go show you one other example. Suppose you're given a picture like this. This is clearly a reflection because ABC has changed its orientation. How do you figure out where the line of reflection is? You can go from C, you can make a line from C to C prime and count 1, 2, 3, 4, 5, 6, 7, 8. So 4 over would be the line of reflection, or you can use the midpoint tool. And let's do another segment from B maps to B prime. Find the midpoint and then do this line tool. And this is the line of reflection. This pre-image was reflected over this line and ended up here. And let me move this back to the algebra graphics view. This line is x equals 2. I hope you enjoyed this video. Thank you.